So I have my own version of this protocol, and I'll promise I'll prioritize putting it on protocol IO as well. If you can't wait to try it out, you can send me an email. I can send it to you. Not immediately, because half of it is still handwritten on in my notes. But just quickly to tell you the difference. So this is not a kit. It's not a homebrew method. And this was developed in collaboration with Sanger Vitol for more challenging plant species. The plant in particular this was developed for is highly vacuolated. So like they use a lot of material, a lot of falcon tubes. So like the main difference between this and the version that I wrote is just like a more manageable amount of tissues and volume. So like here you have something like 10 to 30 falcon tubes per sample, and we don't want that. So the input that I like to work with is at least 1 gram of tissue. It works with less, but that's also a big difference between what you do. So here we also work with bigger volumes. If you're familiar with the protocol for nuclei isolation recommended by Papayo, the former Circolomics kit is very similar. With the difference that here the wash steps are done with the sorbitol buffer. I'm particularly fond of sorbitol because it helps remove particularly polyphenols from tissue before cell lysis. If you have polyphenols in tissue and do a cell lysis, they will bind irreversibly to DNA. You'll never clean them out. I don't think for HiC this is really, as far as I know, it's not an issue. It's an issue when you do papaya sequencing, you want to sequence a native molecule. So that's where I started using it, but I saw it gives me really nice and clean nuclei. So, and it's difficult to know beforehand how problematic a plant is going to be. So I just assume they're all problematic. If I have enough tissue, I'll go for this one. So you have your nuclei isolation buffer, which is high concentration sucrose to cell lysis. Other protocols will continue with this buffer for the blow washes of your pellets. And here we do it with the sorbitol buffer. Yeah, this one.
Yeah, the question. Are you still using the ethanol buffer? Mm-hmm. Yes, so that will remove the polyphenol. Will prevent that from oxidation.
Then it's pretty straightforward. It's in bigger amount of tissue, bigger volume, so we don't process so many samples at a time. But it's just about grinding your tissue in liquid nitrogen. We recommend to grind for a long time. We do see that it really increases the yield if you get a fine powder. Some people say like 20 minutes. It's difficult to set a time because like some samples have a really nice texture consistency after a couple of minutes. Some require more time. I'd like to, when it starts like sticking together like flour, that's the texture that I want, and I'll grind some more to get there. And then you add your nuclei isolation buffer, and you let it lyse for a bit, so keep all of this on ice, and then you filter it through gravity filters, 100 micron, 40 micron. Problem is sometimes, even you use a big volume, so like we're doing this step in 40 milliliters for 1 or 2 grams of tissue, even though you're adding this much buffer, it could have like a very slimy, viscous lysate. Sometimes you can get by with just using multiple filters, keep swapping them out. This has worked for most of our samples. Sometimes you have to switch to filters that you can hook up to vacuum, so that you can get your lysate. Then you do 3 washes with the sorbitol buffer. I would recommend to use a swing bucket centrifuge for this, because you get So the pellet will be a bit more difficult to dislodge, but you lose less during the washes. Again, this is not recommended here. It's from a different protocol. You could increase your centrifugation speed if you know that you have very small genomes, so that helps. Centrifugation speed, you can go up to 5 or even 7,000 if you know that you have a very small genome. So far, because I've tried both options. So we have a swing bucket centrifuge that goes up to 3,000. It has worked for most. We recently got a new centrifuge with a fixed rotor for Falcon tubes. So I tried centrifuging more for small genomes. And sometimes it feels like it helps, but then the pellet will not be at the bottom, but on the side. If the pellet is still very sugary, it will slip off the Falcon tube. So yeah, try and see. Also, I think the 3 washes do make a difference. Sometimes you have to cut your losses. If you see that from wash to wash, you're losing too much, then I would recommend maybe doing 1 less. So with the last wash step, we then switch to a smaller volume so that we can aliquot. You can either aliquot the nuclei at that stage, or we can go directly into the cross-linking and aliquot them afterwards. But yes, the last step, we just switch to a smaller volume. So then we go to the ARIMA protocol for plant tissue, but cross-linking, so we go in with the nuclei, cross-link them, and this is easily, if you're not processing too many samples at a time, this is easily something you can do immediately afterwards. So you can, there is a safe stopping point after nuclei isolation, you can snap freeze them, keep them at minus safety, but it's really easy to go directly into cross-linking. So at the end of the day, you have your cross-linked nuclei. Yeah, this is it. And then usually if the pellets are decent sized, we aliquot them out into 10, 20, 30%, and proceed to input estimation.
So the difference between this is very cheap to do, right?
Yeah.
Yeah.
I would definitely not try this on 100 milligrams of tissue. I think it really depends, right? Because like you could have very small leaves with lots of cells and still get a good yield out of less tissue. I think I'm comfortable going down to 400 milligrams for this, but not 100. No, I think then I would order myself one of those kits. It's not strictly necessary. It's also because for us, I started using it when I saw that it rescued a couple of samples that wouldn't sequence well on Papaya. But it doesn't really add time to my protocol, and it doesn't do any damage. So I've started using it as a standard step. So if I'm not doing nuclei isolation, I like to wash the powdered tissue with sorbitol before I go into tissue lysis. Sometimes it really helps.
So are those extra washes on top of like nuclei isolation buffer washings?
I mean, most nuclei isolation protocols, at least the homebrew versions, recommend 3 washes. And then again, I mean, you're free to do less or more depending. So I'm basically substituting the 3 wash steps with just a different buffer, because you could wash with your nuclei isolation buffer. There's nothing against that. I have played with the idea of doing nuclei isolation on some other slimies, but I wasn't sure if you could just like one-to-one use a plant protocol. I did sorbitol wash the cryoprepped tissue from our snail. I have no idea if it helped because it still didn't sequence, and I think we figured out that had a different reason for not sequencing. But in terms of handling it, and the DNA was super clean, so I think, and again, it doesn't damage it or anything. So yeah, sorbitol has my seal of approval.